Hello. Buenas noches. We're going to go ahead and do Unit 5, Lesson 17 today. So whatever you aren't able to get done in class will just be homework. You can watch this video to help you finish it. But we're going to knock it all out. So let's do it. Grade 8, Unit 5, Lesson 17 says scaling one dimension. You may or may not remember, you've actually done this before. We're just going to be applying this now to cones and cylinders. But nevertheless, let's get started. Let's look at the warm-up here. And whatever, blah, blah, blah. Here is a graph of the amount of gas burned during a trip by a tractor-trailer truck as it drives at a constant speed down the highway. At the end of the trip, by the way, the end of the trip is right here. How far did the truck drive? And how much gas did it use? I don't think you need my help. Go ahead and write your answer for A. Question B says, if a truck traveled half the distance going at the same rate, meaning on that same line, find half the distance and then find out how much gas it used. You might be able to do that in your head without even looking at the line. And then question C says, if a truck traveled double this distance, how much gas would it use? Well, you could actually do a lot here, but don't make this any harder than it needs to. But you could actually figure out how many miles per gallon it's going and then do all that. But you could probably, again, figure that out without doing much math. You could just say, well, this is how much gas it used in that. And you'll notice if you double the distance, you'll double the gas. So, and then finally, it says complete the sentence. Blank is a function of blank. Do you remember that on a graph, the y value, the up and down, is a function of the left and right. The y depends on x. Y depends on x. So again, you can cross out that word function and write the word depends. And then if you look at that graph, you can look, oh, this depends on that. And it makes sense if you say it the way it is. Gas burned, well, the amount of gas you burn, it all depends on how far you drive. The number of distance traveled. So let's move on. Activity 1, double the edge. And I guess I should go back and see this whole graph. If you notice, if we doubled the distance, the gas doubled. If we halved the distance, the gas halved. Guess what? Guess what you're doing that whole time? You were scaling one dimension. And guess what happened to the other dimension? It's scaled by the same thing. When one thing doubled, the other thing doubled. If we were to triple that, guess what? The gas would triple. That's how simple scaling one dimension is. You've done it with rectangular prisms. We'll talk about that more in just a second. Right here we will. And that will transfer directly to cones and cylinders. At least you'll recognize it with cylinders. Cones, it also works. But it's kind of harder to visualize. At least it is for me. But here we go. Let's do activity 1, double the edge. This is its title. There are many right rectangular prisms with one edge 5 units and another edge 3. It says a right rectangular prism. Let S represent the length of the third edge. So first off, I'm just going to draw a rectangular prism. It's going to be the best rectangular prism you've ever seen. It says right here, one edge is 5. So let's call this 5. One edge is 3. Let's call that 3. Let S represent the edge of the length of the third edge. So here's 5. I want to make sure it looks like a 5 because here's S. Let's call that third one is S, right? S represent the length of the third edge, and V represent the volume. Write an equation that represents the relationship between V and S. Well, hopefully we recognize or remember the volume of a prism is length times width times height, or the base of something. Sometimes they'll write it like this. Volume is capital B times height. That base is a length and the width. So don't ever think, oh, it's B times height, the width. No, B is the base of an item. In this case, if I were to draw it, it would be this dotted area. That would be the base. And then we'd times it by the height. But nevertheless, just for the most part, remember it's length times width times height. So let's write that. Volume equals, and this time it's going to be 5 times 3, or 3 times 5 times S. And that's supposed to be an S and not look like my 5s. Or I could write volume equals 15S. Okay, my S's are just struggle. In other words, I just did 5 times 3. But I could do that in any order. S times 3 times 5, S times 5 times 3, 5 times S times 3, doesn't matter. But long story short, we're taking the base, if we're going to call it that, it's just 15, but it might not be the base because we don't know really what sides it's talking about. But we're taking that 15 and multiplying it by whatever that third side is, and then we'll get the volume. So that's all we know. We don't know what the other side length, but it says graph this equation and label the axes. So let's think here. What depends on what? This kind of goes back to what does our volume, depending on the side length, does our side length depend on the volume? If you look at the way we wrote an equation, this V is doing a lot of depending. It is depending on what we do with that third side length. So guess what? That means volume is going here. And that means the side length is going here. And let's think about this. So let's plug in some numbers. What's the easiest numbers we can do? Well, what if the side length was 1 and 2 and 3 and 4 and 5 and 6, 7, 8, 9, 10? Well, what are we going to count by with volume? Since everything is going by 15 times 1, 15 times 2, well, we might as well count by 15s. Guess what? That'd be right there. And then if the volume is 2, I'm going to write V equals 15 times 2, which means the volume is 30. So I'm making it easy on myself. And just scaling this exactly like it would go here. That's probably not the best scale because I'm not using this part of the graph over here, so why would they have given me that? So maybe I should have counted otherwise, but so be it. And if that was 10, 15 times the edge length was 10, then we know that this must be 150 because 15 times 10 and so forth. In other words, if I would have just counted, I would have gotten 60, 75, 90, 105, 110, no, 120, 135, and then 150. But nevertheless, there's a graph. Now, what happens to the volume if we double the edge length S? So let's look right here at this point. If my edge length was 4, my volume was 60. The edge length, S was there, volume. If I double the edge length, if it went from 4 to 8, well, if I go right up here to 8, what is my volume here? Well, 60, I guess I am going to have to count this out. Great, just great. 105. Oh, don't do that. What are you doing? Drawing? This thing. Knock it off. Knock it off. Drawing. What am I drawing? That would be 120. And by the way, look, the edge length doubled. Guess what? So did the volume. And we pretty much summarized this lesson. Now, of course, this is with prisms. We're not interested in prisms. We're interested in cylinders and cones. So we'll have to see if this is the same with cylinders and cones. But it says, where do you see this in the graph? Well, I just showed it to you right there. It went from here to here, and it went from here to here. Where do we see it algebraically? We didn't bother doing it algebraically, but if the equation was 5v equals 15s, algebraically means what equations, like algebra means equations and stuff like that. So if our equation was v equals 15s, well, we would say v equals 15 times 4. Whoops, why did I write a 0? That equals 60, and v equals 15 times 8, and that equals 120, so we can clearly see it algebraically too. All right, so now for the real thing, because hopefully, believe it or not, you have done that before, because that's what you did in 7th grade. There are many cylinders, so now we're going to transfer this to cylinders. Cylinders with a radius of 5 units. Let H represent the height and V represent the volume. Write an equation for this. Well, first thing, it says use 3.14. Oh, great, I don't have a calculator. I will just use the handy dandy. So guess what? We're going to write, I do know volume equals pi r squared h, and I'm going to replace everything. The volume tells me blah, blah, blah. Don't know the volume, so guess what? I'm going to leave that V. There are many cylinders with a radius of 5. Volume equals pi is going to be pi. Well, it says use 3.14 times r. Tells me the radius is 5 right up here. Times 5, and then we're going to square it times height. So 5 squared, by the way, is 25. 25 times 3.14. 25. By the way, that little star sign also can mean 25 times 3.14 is 78.5. What are the odds? Don't do that. Thanks for wasting everyone's time. What did I just say? 78.5? Gosh darn it. Yeah. So guess what? Volume equals 78.5 times whatever the height is. I went ahead and did all that. Got 78.5. Volume equals 78.5 times the height, and there's my equation. So, graph this. Great. If the height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. So let's just stop right there. If, first off, the height is 0, guess what? We have nothing. We don't have 3 dimensions. We have nothing. the 0. If the height is 1, then we have 78.5. But I'm going to go ahead and just plug in 16. What if the height was 16? I'm going to write volume equals 78.5 times 16. Let's use dots. So 78.5 times 16 times 16, and I get 1256. So I have to go ahead and say whatever it is, somewhere up around here has got to be 1256. So what could we count by to get 1256? We want 1200 somewhere around here, maybe 1300 somewhere around here, who knows? But let's see. Let's count by hundreds. 100, 200, 300, 400, 5, 6, 7, 8, 9, 10, 11. So counting by hundreds was not enough. So let's go ahead and count by, this won't be the best thing, but if we counted by 200s, 200, 400, 600, 800. Stop that. What is this? It's just on me. Nope. What you're doing here. But you are going to really make me happy. 1,000, 1,200, and 1,400. All right, so we know that we need 1256, I believe. Is that what I said? I'm going to pretend that's what I said. So if 1,200 is right here, we go 1,600, 1,200, 1,300 would be here. So half of that would be right here. So not the best of scale, because you usually want it to go up a little higher, but not the end of the world. So now I'm going to draw as straight as line as possible. Let's use blue. I'm going to hold my hand so steady as possible. And it's going to be roughly something like that. We're not in it to win it, but that'll be good enough. So, there it is. That's if, first off, we can see what happens to the volume if you have the height. Well, the volume, stop that. Volume was 1256 when the height was 16. Well, what happens when the height is 8? It says if we have the height. Let's go from 1256, let's go to 8 and see what we get. And you'll notice that's going to be 600 and something, which, believe it or not, the actual real life answer would be 628. How do I know that? Because if this gets cut in half, guess what? That's what happened here. I can see it right here on the graph. That is going to be about 628, and lo and behold, it is right about 628. Where do I see it algebraically? Well, we did volume equals 78.5 times 16 and got 1256. Well, let's do 78.5 times 8. And guess what I get? I'll get out my calculator. Oh, I got 628. So we see it algebraically, and we also see it on the graph. I don't know what that sounds like through your headphones, but hopefully it's really annoying. All right, and that is about all we have time for, really, but this is the exact same thing, except it's with cones, and they did the graph for us. That was nice of them. Volume of a cone, height of a cone. What do the coordinates of this mean? Go ahead and write down your answer. I'll give you a clue. It has something to do with volume and height. What is the volume of a cone with a height of 5? Well, you just get to guess. Don't worry about being exact, I guess. And a height of, we don't know at 30. So guess what? We are going to have to be, because 30, there's no height there. So maybe we need to be exact. And I guess we can be because we know a piece of information right there. I know the volume of a cone is 1/3 pi r squared h. And if the volume is 10, then it's 1/3 pi r squared h. But I have that wrong. The volume's not 10. The volume is 2355. And 10 is the height. So I'm going to erase h and we're going to write 10. And if you remember, this time there is no pi, by the way. It doesn't say it's in terms of pi anywhere. So I have to take 2355 and times it by 3. If I want to get rid of this 1/3, I got to times it by 3. Technically, I'm multiplying each side by 3. 3 times a third cancels. 2355 times 3, I could get out my calculator, but every once in a while, I like to just remind myself how to do the old-fashioned way. 10. I got 7065. Let me get rid of this arrow. That's equal to pi r squared times 10. Well, I'm going to divide each side by 10 to get rid of this 10. And that's just 706.5 equals pi r squared. That's now canceled. All I have to do is move that. Now I have to divide each side by pi. Divide this side by pi, and this is going to be interesting. I get r squared equals, I'm hoping I got an even number, 706.5 divided by 706.5 clear. 706.5 divided by 3.14. Oh, thank goodness it gave us 225. So that equals 225. Why is that so nice? Because then I know I have to think r times r equals 225. And if I don't know how to find that answer, guess what? We're going to take the square root of 225. The square root of 225, and 10 times 10 is 100. 20 times 20 is 400. Can you guess what it would be? Yes, it's 15. So guess what? We found out the radius is 15. Well, why did I have to do all of that? Because now I can plug in the numbers. What's the volume of a cone with a height of 5? Well, we had to do all of that because we know the radius now is 15. So now I can go volume equals 1/3 pi. R is 15 times 15 squared times 5. And I'll get an answer. And then I can do the same thing with a height of 30. I can plug in 30 right there. So a lot going on. Crazy problem. But you're going to notice, well, it says write an equation that relates the volume and the height. Volume equals 1/3 pi times 15 squared times 225, or 15 squared. Let's just use 15 squared since times 15 squared times height. We don't know that. We were able to figure out what the radius is. Use the label point to find the radius of these cones. I'm wondering, how did it... I think what it was just wanting you to do there, I think I made it much too complicated, although we definitely needed to do it down there in D. But at the volume, if the height was 5, oh, duh, yeah. Sometimes I'm not looking carefully at it. It's just saying, if we look right here, if the height was 10, then guess what? Whatever that is, if if we changed, if the height it's to 10, if we change it to 5, well, we just cut that in half. So I should have cut that in half, and I would have easily found that out. And then if the height is 10, well, if I triple this, times it by 3, all I needed to do is times this by 3. Yeah, I definitely made it a lot harder on myself. But hey, that's the beauty of math. That's when like guess what? I won't probably make that mistake again, just because I went through that whole rigmarole and then I looked at that and go, oh, duh. That's when your brain learns best. Like my brain, all the neurons were firing crazy right there, as opposed to if I just had someone just say, this is what you do. Oh, great, thanks. So, all right. That's about it, guys. We're going to go ahead and call it good. I just want you guys to do, I won't assign it all, just do problem 1 and 2. Call it good. Problem 2 is pretty straightforward, and guess what? Problem 1's a lot easier than you think, because if we know the volume is 48 pi and the height was h, guess what the volume is going to be if we double the height? And 5 times the height. So that shouldn't take but a minute if you're looking at that carefully. And then this just means having the height in 1/5 or taking the height. That means the same thing's going to happen in the volume. So long story short, what we should do to summarize this lesson is, guess what? When we're changing one dimension, and by the way, we were only changing one dimension down here, which was the height. We're going to learn tomorrow things are way different when we change the radius, because believe it or not, the radius is not one dimension in these formulas. Radius squared, that's changing 2 dimensions. Well, all we did today, all day today, is change 1 dimension. We'll worry about that tomorrow. So that's it for now. Peace.